All right, we're going to do lesson 2-9 actually with our chapter 2 mini unit. Our mini unit's going to have everything to do with exponents and powers and things like that. So um, we're going to use chapter 2 lesson 9 here for the beginning of this little mini unit. All right. So a power, base, and exponent, they all kind of all go together here. So if I have 3 to the 5th, okay, the base is 3. So this here is my base, and then my exponent is up here. Okay, and then what this means is we're going to do 3 times 3 times 3 times 3 times 3. The number up here, the exponent or the power, tells us how many, 1, 2, 3, 4, 5, tells us how many factors we're going to have, and the base tells us what the factor is. All right, so it's kind of like what number should we see? That's going to be answered by the base, and how many of them is going to be answered by the exponent or the power. All right, so we use powers and exponents to represent large numbers, or we could use it to represent really small numbers. So, for example, if we're going to write 1/3 times 1/3 times 1/3 times 7 using exponents, what you're going to do is you're going to write down the numbers that you see. So 1/3 is a number that I see, and 7 is a number that we see. So we're going to multiply times 7. Now, the question is how many 1/3s are there? And that will be your exponent, 3. And how many 7s are there? And there are 2. Okay, notice that I put parentheses around the fraction, but I didn't around the whole number. Okay, if I were to have written 1/3 and then this cubed, what that means is we're going to do 1 times 1 times 1 all over 3. Okay, now 1/3 in parentheses cubed means 1/3 times 1/3 times 1/3. Okay, that's a big difference because if we do this, we're just going to end up with 1/3 again. And if we do this, we're going to end up with 1/27. These two items are not equal. So it's really important that when you have a fraction and you're writing it using exponents, that you include parentheses around your fraction to show that we want to multiply the whole thing 3 times, not just the top number. Now, with a whole number, you don't really have to do that. You can if you want. You could put parentheses around the 7, but you don't need to because this means 7 times 7 or 49. Now, it didn't say to evaluate. It just says write it. So we're actually done with this problem at this point. Okay, so for this one, I see a 2, so I'm going to write a 2 times, and I have a 5. All right, now how many 2's? 1, 2, 3, 4. And how many 5's? 1, 2, 3. All right, so this would be how to write this using exponents. I see my box here got cut off a little bit. So there it says using exponents, okay? So we'll go to the next example. Now, it's the same thing when we're doing this with letters. So I see that I have a P and then I have a Q. So I'm going to write P times Q, and then I just need to count and see how many there are. So P's, 1, 2, 3, 4. So there's 4 P's, and Q's, 1, 2, 3. All right, so P to the 4th times Q to the 3rd. It doesn't matter if they're in a different order. So here I had some P's, and here's another one. I'll just combine all of them to say 4. It doesn't matter if they're in any different order at all. Okay, so now I have an X and a Y, so X times Y. Now I just count them. So here's 1, 2, 3 X's, and 1, 2, 3, 4 Y's. All right, so I just count them up, and the order doesn't matter because multiplication is commutative, so we can write them in any order. It will be the same value. You could try this by putting like a 2 in for X and a 3 in for Y, and actually multiplying this out, and then doing it again with exponents. 2 to the 3rd times 3 to the 4th, and you're going to get the same answer. You could do that always to check. Okay, any non-zero number to the 0 power is 1. Any non-zero number to the negative n power is the multiplicative inverse of the nth power. So for example, any number to the 0 power, any non-zero number to the 0 power is going to equal 1. So 5 to the 0 equals 1. 7 to the 0 equals 1. Okay, x to the 0 equals 1, as long as x does not equal 0. So that's what it says here. X cannot equal 0. So it can be a negative. It can be negative 1 to the 0 power, and that equals 1. Okay? Now, as we see right here, okay, if we have a negative exponent, any negative exponent, so 3 to the negative third, we could rewrite that as 1 over 3 to the third. Okay, just like that. So it's a way to write everything kind of looking like a whole number. But then the negative exponent says that we can, is the power, negative n power is the multiplicative inverse of the nth power. So they're equal to each other, the multiplicative inverse, okay, that 1 over 3 to the third. Okay, that's kind of what we talked about last chapter 2. This does work with negatives as well, so if I have a negative 2 to the negative first power, I could write that 1 over 2 to the first power. The whole thing is still negative. I can leave the negative with the 2, or now it's like negative 1/2, because to the first power it'd just be 2, it'd be itself. Okay, so probably the new item here that we have to think about is that anything to the 0 power is equal to 1, and if you have a negative exponent, we can flip that over and write it as a reciprocal with a positive exponent. Well, let's try it out. So now it does say to evaluate, so we are going to go ahead and work this problem out. So we have 3 to the 4th, or excuse me, 3/4 to the 5th power, which is going to equal 3 times 3 times 3 times 3 times 3 all over 4 times 4 times 4 times 4 times 4, okay? Basically, that's 3/4 times 3/4 times 3/4, but we know that when we multiply, we just multiply straight across, so it's fine to do it this way as well. So 3 to the 5th, or all those 3's, is going to be equal to 243, and 4 to the 5th is equal to 1024. Okay, obviously it'd be nice for us to check to see if we can simplify that at all, but I don't believe that we can. If we go 2 plus 4 is 6, plus 3 is 9, obviously we know it's going to be divisible by 3 and 9. If we add these up, we get 6 plus 1 is 7. That's not going to be divisible, so we could be done right there. Obviously, if you divide that out, you're going to get a really ugly decimal, so we'll just leave that as a fraction. Okay, same thing, so 3/5 to the 3rd power. So what that means is 3 times 3 times 3 all over 5 times 5 times 5. All right, and so what we're going to get here is 27, and 5 times 5 is 25 times another 5 is 125. And if you were to check to see if you could simplify that, we'll find out that we can't. And so that's our final answer. So 3/5 to the 3rd power is 27 over 125 when we're asked to evaluate the expression. All right, so it says evaluate 3 to the negative 7th power. So 3 to the negative 7th power is the same as saying 1 over 3 to the 7th power. Okay, so if you want, you can just go ahead and use your calculator to figure out what is 3 to the 7th power, and that's going to be 2,187, okay? So when they're a little bit smaller, you know, like to the 3rd power, it's nice to see you write it out so that way you're practicing knowing what that actually looks like. You know, if we get up there into like the 5, 6, 7s or higher, it's okay to just excuse me, it's okay to just use your calculator to figure that one out. But I do want you to show me the work here. So copy 3 to the negative 7th, and then show me that it turns into 1 over 3 to the 7th, and then you can use your calculator. I do want to see you copy and convert it to a positive exponent by writing it as a reciprocal or multiplicative inverse. So let's do that again. Let's go 2 to the negative fifth. We're copying it. Now we're going to write it as a positive exponent as 1 over 2 to the fifth. Okay, and you can use your calculator here. 1 over 2 to the fifth power is going to be 32. And that would be your final answer. Okay, so again, this practice of if you have a negative exponent, we can rewrite it with a positive exponent as the multiplicative inverse. All right, so now we're going to evaluate, so we're going to solve it. So x cubed, where x is 4. So we're going to say 4 cubed times y is 2 to the fifth, okay? If we had a common base here, we'd actually be able to do something. We'd be able to combine the exponents here a little bit, but we don't have a common base, so there's nothing common for us to combine. So we just got to find out what is 4 to the third. It's okay if you want to use your calculator, we'll get 64. Otherwise, we kind of do that in our heads. We go 4 times 4 is 16, times another 4 is 64. Times 2 to the fifth, and that's going to be 32. We just did that one. Now, when you do your homework here, I would like to see you break down each step individually. So how I went from 4 to the third to 64 and 2 to the fifth to 32, rather than just going straight to my answer. Okay, and then we can do 64 times 32 to get 2,048. Okay, so I would like to see at least this much work. Show me that you're substituting, show me that you're following order of operations, and then you can solve. Okay, so x is 3, so 3 squared times y is 4 to the fourth power. So 3 squared is 9, times 4 to the fourth power is 256. So again, I'm showing the work of breaking these down. Then I multiply those two together, and I'm going to get 2,304, okay? So I would like you to show me this work. You know, it might even be helpful for you to copy this first part, x squared times y to the fourth. I'm obviously not doing that just because I'm writing on this page itself. But when you're doing your homework, it might be helpful to copy this down so that way you don't make any mistakes on substituting. Okay, so now we have some numbers with common bases. I kind of mentioned that before. If you have common bases, you can actually do some things here to cancel this out. I'm going to write this out just so you can kind of see what it looks like. So it's going to be 3 times 3 times 3 times 10 times 10. All right, divided by 3 times 3 times 10 times 10 times 10 times one more 10. Okay, so now you remember when we were doing fractions, and I always said to simplify before you multiply. So if I had this, and then I said 5/6, okay, you could simplify the 2 and the 6 to be a 1 and a 3, and then you multiply to get 5/9, okay? We basically are doing the same thing here. This is a fraction, so we can actually simplify before we multiply, okay? It's all the same thing. So we can simplify this 3 and this 3, this 3 and this 3. They basically just cancel. They all turn into 1s. And then so I can do this 10 and 10 and this 10 and 10. So what am I left with? I'm left with just 1 3, and 10 times 10 is 100. So I have 3 100ths left after I'm done with that. Okay, so this is kind of how I'd like you to do this. When you see problems like this, I'd like to see you write them all out for this lesson today. There's actually another way you can do this. But for today's lesson, I want to see you write them out and just cancel them and then show me what you have left after you, and then you can go ahead and multiply whatever you have left. Here we couldn't multiply because we only had 1 3 left. So let's try it again. This is, you know, we're going to be writing out quite a bit here, but that's okay. That's what I want. 4 times 4 times 3, 1, 2, 3, 4, 5. And then we have 1, 2, 3, 4 2s all over. This is a big fraction. So I'm going to have 1, 2, 3 4s, 1, 2, 3, 4, 5 3s, and 1, 2 2s. So, simplify before you multiply. So I have 2 4s, and I'm going to get rid of these 2 4s. I can't get rid of that one, so that one's going to stay. I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So all my 3s are actually going to be gone. And you could have probably seen that was going to happen right here because you have the same thing on the top and the bottom. So if you notice that, if you notice you can get rid of a whole number because it's 3 to the 5th and 3 to the 5th. If you notice that and you didn't want to write it, you could maybe just write 3 to the 5th when you're writing it out and 3 to the 5th, and then just cross out the whole 3 to the 5th. Okay, otherwise if they don't match, so this is a 2 and this is a 3, this is a 4, this is a 2, write them out for me, okay? So we're going to cross off 2 2s, get rid of 2 2s. So on top, I don't have anything here but these 2 2s. So I'm going to end up with 4 over. Okay, now on the bottom, all I have is 1 4. So I'm going to have 4, which is equal to 1. So after we do all of this, we just end up with 1 for an answer. Because the only thing we have left is just 1 4. We're left with 2 times 2 here, which is 4, and we're left with one of these 4s. So our answer ends up simplifying to just 1. Okay, so this is how I'd like you to do these. Over the next couple lessons, I will be showing you how to do this in another way. And that was your last example here for lesson 2-9. This is our first lesson of our mini unit. Be sure to check the Moodle page for your homework.